Hi friends, through this video we will learn classification of queuing models and some important formulas for to do the problems in simple model. Classification of queuing models should be classified as a three-part. One is probabilistic, one more is deterministic, and one other one is mixed model. In a probabilistic model, the both arrival and service rate are not to be a constant. If not to be a constant means it must be a random variable. In deterministic model, it is an opposite of the probabilistic model. The arrival rate and the service rate must be the constant. Mixed model, either arrival rate must be the constant or service rate must be the constant. If one of them is constant and another one must be the random variable it is. And the next, this little formula will reduce your burden of memorizing the formula. The little formula 1 denotes the waiting sign number of the system should be calculated with the help of the average number of customers in the system. That is, Ws is equal to Ls divided by lambda. And the second formula denotes Wq is equal to Lq divided by lambda. And the third formula is Ws equal to Wq plus 1 divided by lambda. And fourth formula is Ls is equal to Lq plus lambda by mu. And if this formula is denoted, L is equal to W lambda. You can use this idea. So if you are keeping this one in your mind, it is easy to remember the first two. For the next, we'll look upon the models and what are the formulas we are using to do the problem. The first model is MM1 model with infinity FCFS. Actually, the first M denotes the arrival process must be in the Poisson, and the second M denotes the service must be in the form of exponential process, and the third one denote the number of servers in the system must be 1, and the infinity denote here the capacity of the system must be infinity, and discipline of queuing is, that is queuing discipline is FCFS, first come first serve. What are the model we are reading here? It must be in the arrival process and the service process must be the Poisson and exponential respectively. That's why it is mentioned MM like that. The models in the first model we are having the one server, and the second model you have C number of servers, and third model you are having again one service and again you have C number of servers. In first model and second model you have capacity of the system must be infinity, and third model and fourth model you have the finite number of person can stand in the queue, that is you have K, and all the models are having the same queuing discipline FCFS. The traffic intensity formula for the first model is rho is equal to lambda by mu, and it is almost similar to all the models. And while you are having the number of server must be C, then you can use instead of mu as mu C, that is the traffic intensity is denoted by rho is equal to lambda divided by mu into C. The probability of an empty system or a server to be ideal our customer gets service immediately is equal to P naught, and it is represented in the first model P naught is equal to 1 minus lambda by mu, and it has a formula for the second model is looking like that, and third model and fourth model. I don't want to read all the formulas here. During problem itself I will explain and what are the formulas we are using and how we have to do. If you are looking the formula for the second one, the probability having a n customer in the system, it is denoted by Pn, and the effective arrival rate, it is not there for the first model and second model, and the third model and fourth model, effective arrival rate is denoted as lambda dash. That is different from other two model. The average number of customers in the queue is denoted by LQ. It is represented here, and average number of the customers in the system, it is represented here, and the average number of waiting time in the customer. While you are finding LQ and LS and WQ and WS, you can use the Little's formula. You don't want to memorize all the formulas. Especially, if you are memorizing these things, it is better. The first model you can memorize LQ, and the second model you can memorize LS, and the third model you can memorize this one, and the fourth model if you are memorizing this one, it is instead of memorizing these four formulas, you have to memorize what I rounded here, that is, and the average customers in non-empty queue who have to actually wait is LW, and LW having formula only for the first model and second model, we are not having for the third model and fourth model. And the special formulas it is mentioned here. While doing the problem, I will just recollect the form. These are the formulas you have to memorize, students. Thank you.